In order to do division with fractions, we need to define what are called reciprocals. Reciprocals are any two numbers whose product is 1. So for instance, 1/3 and 3 are reciprocals because 1/3 times 3 comes out to be 1. Likewise, 2/5 and 5/2 are called reciprocals because 2/5 times 5/2 comes out to be 1. Now we use the idea of reciprocals to give a definition for division with fractions. The fraction a over b divided by the fraction c over d is exactly the same as a over b times the reciprocal of c over d, which is d over c. So to divide by c over d, we multiply by its reciprocal d over c. So division by a fraction is the same as multiplication by its reciprocal. Let's try an example. 25 over 46 divided by 40 over 69. I'm going to start this by changing from division to multiplication. The first fraction stays exactly the same as it is in the original problem. Then I change to multiplication and I multiply by the reciprocal, 69 over 40. The next step is simply to multiply, just like I did in the previous section. So I'm going to do my multiplication by simply multiplying and factoring completely. So 25 is 5 times 5. 69 is, let's see, 69 is 2 times, no, it's 3 times 23. 23 is a prime number, so I can't factor it further. 46 is 2 times 23. And then 40 is 4 times 10, which is 2 times 2 times 2 times 5. So there's my numerator and denominator factored completely. Now I'll divide out common factors, divide out the 5s. Let's see, I've got a 3 here and a 3 over, I don't have another 3, oh, I think I did that last time. Whoops, I have a 3 right here and no other 3's in the denominator. Now I have a 23 here and a 23 here. So now what's left in the numerator is 5 times 3, which is 15. What's left in the denominator is 2 times 2, which is 4, times 2 is 8, times 2 is 16. So 15 over 16. And you can see what I almost did there. I almost divided out this factor of 3 with the 3 and 23, which of course you can't do. So I can only divide common factors from the numerator and denominator. I have a common factor of 23, which I can divide out, and another common factor of 5, which I can divide out. But here's the idea behind multiplication. Behind division. To divide by 40 over 69, I simply multiply by its reciprocal, 69 over 40. That's the only thing that's new in this section. Here's another example. 20 divided by 1/10. 20 divided by 1/10 is exactly the same as 20 times the reciprocal of 1/10, which is 10. 10 over 1, or 10. 20 times 10, 200. So to divide by 1/10, we simply multiply by its reciprocal, 10. 20 times 10 is 200. Another way to look at this, if you're thinking in terms of the kind of the old definition for division, how many 1/10ths are there in 20? Well, it turns out there's 200 of them. There's 10 of them for every 1, and here I have 20. So 20 times 10 is going to give me 200. So it makes sense intuitively, too, besides the new definition. Let's look at our next example. I have x squared over y cubed divided by x over y squared. I'm going to rewrite this as x squared over y cubed. I don't change the first fraction at all. Then I change division to multiplication by the reciprocal. So instead of x over y squared, I have y squared over x. Next, I factor the numerator and denominator completely. X times x times y times y. All that's over y times y, because it's y cubed, times x. Now I divide out factors common to the numerator and denominator. I can divide out an x, and I can divide out that y with that y, and that y with that y. What I have left in the numerator is x, and what I have left in the denominator is y. So that fraction reduces down to simply x over y. And again, the only thing new in this section is that division by a fraction is the same as multiplication by its reciprocal. Here's our next example. 10 divided by 1/2 squared. Let's take care of that exponent first so that we're following the rule for order of operation. 1/2 squared is 1/4. Now 10 divided by 1/4 is the same as 10 times 4 over 1, which is just 4. 10 times 4 is 40. So this time I included the rule for order of operation. I squared this 1/2 first, and then I changed my division to multiplication by the reciprocal. Another example. Problem number 5. 10 plus 11/12 divided by 11 over 24. So I'm going to use my rule for order of operation and write this as 10 plus, now I hope I don't have to add fractions here because I haven't done that yet, 11/12 times 24 over 11. Now if I multiply these out, divide out common factors, this is going to be 10 plus the 11's divide out, that factor that's of 12 that's common to those two divide out, and what I have left is 2. So 11/12 times 24 over 11 is 2. 10 plus 2 comes out to be 12. So again, another problem in which I use the rule for order of operation first, and then in the process of simplifying the expression I have to do division with fractions. Here's another example. Written in words, I have the quotient of 18 and 3/5 is increased by 10. What number results? Okay, the quotient of 18 and 3/5 is 18 divided by 3/5. That quotient then is increased by 10, so I want to add 10 to it. Okay, 18 divided by 3/5 is the same as 18 times 5/3. Now when I say 18 over 1 times 5 over 3, that 3 will divide into that 18 6 times. That's the only common factor in the numerator and denominator here. So that 6, 3 divides into there 6 times. 6 times 5 is 30, plus 10, and I end up with just 40. So you will notice as you go along a few shortcuts that you can apply here and there when you're reducing these products to lowest terms. When you first start working these problems, though, I think it's a very good idea if you simply factor the numerators, factor the denominators completely, divide out all the common factors so you can see your work, and then show what you get in reduced form.